let's go over number one.
Alright.
Hold on, make sure my camera's going for this part. Good. Okay.
Alright.
Tell me what you got for number one.
Okay, for number one, I got 12.6 milliliters of paint.
Tell me how we got that.
Well, what I did was I set it up as a ratio or proportion, so I put 6 milliliters over 56 centimeters height equals X milliliters over 168 centimeters height.
And where did you get 168 from?
And then I just tried to find K, so 168 divided by 56 is K, and then I multiplied K by 6. K was 2.1.
Okay, what does K stand for?
K is the proportion between this and that.
Okay. So is that your scale factor?
Yeah, basically.
Okay, so you have a scale factor of 2.1. So basically you're saying you need 2.1 milliliters for every 56 centimeters?
No, for every 56 I need 6.
Okay, but
for every single milliliter I get 2.1 centimeters of height.
Okay. Let me ask you a question.
Oh, I forgot to account for Y. Yeah, you're right. Ruler.
So what does that mean? You forgot to account for its width?
So I basically, instead of just doing height, I forgot to also include that it goes wider.
Okay.
So
go ahead and work on that.
Okay.
Add that to it.
Okay. So say 1.5 centimeters stands for 56, and these are proportional, right?
I don't know if you can actually include that it doesn't give you the width on there.
Yeah.
So how could you figure out the width if it's proportional?
Well, if these are proportional, then I can just...
Well, but I'm saying if you can't measure it exactly proportional, if they are proportional in size, you have this... Well, let me figure it out.
Let's see. If he's that tall, can I assume that the sketch is square and the sketch is inside of it? It's all painted?
Say that again?
Can I assume that it's square, right? So this would be, say, 56 centimeters and 56...
No, we can't assume that.
Okay. Well, if I know it's 56 centimeters high, and this here, this entire thing, 50, no, 6, 9, so, I really have no idea.
Well, let's try something else. How much more is, let's see, how much more is 168 in comparison to this one?
Oh, how much more paint is used?
No, how much larger is this one?
Oh, okay.
In height?
112 centimeters. I mean, what? Yeah, centimeters. 112 centimeters.
Okay, well, but how much in proportion? How much of a proportion is this to this?
2.1 times.
2.1? You did 168 minus 50 divided by 56?
No, because in proportion, this times, so 56 times 2.1, if you multiply that, you get 11 goes up, and you get, no, this is there, and you get 168 centimeters. So this times 2.1.
That goes in there 2.1 times? Okay. Let me double check your math there, because what's 168 divided by 56?
0.000. That gets there 2 times. That gives you 56. So you fit that in 0.1 times.
So it's 2.1 times larger.
Yep.
Okay, let's move down to the second one, because you're right, you do have to bring the width into it,
But I'm not sure how.
but you just need, maybe I'll let you go back and work on that one.
Okay.
Okay, why did you pick D on that one?
Well, I also set that up as a ratio because I just put them the water, or I mean the feet, thinking about this one, the feet, the length say by the width, or width by length, doesn't matter. And I noticed they were all 3 less, but when you have more pieces, each piece is smaller, so basically the square would be, the sides would be more equal.
Okay, so
I picked.
Isn't this one also 3 feet longer on this side than on this side? Isn't this one 3 feet shorter? So
Actually,
does that matter?
Yeah, it does, because, well, let me see, because if you have, let me see. You have, yes, it does. Because just when you add more feet, overall, 3 feet less is less of a difference overall.
So is that a proportion as well?
Yeah.
So the larger you are, the less.
Larger numbers. If you keep what you're subtracting the same, if you don't increase it with the proportion, I think it stays the same.
Okay. And number 3,
Okay.
you said they're equal. Why would they be equal?
Yeah, because if you have 1 to 3 and 2 to 6 and you simplify it, it's equal.
What if I told you that this one has twice as much orange juice? Would that change your idea?
It has twice as much orange juice, but it's not twice as, quote, orangey because it also has twice as much water.
That's correct. Very good. All right, and the last one, what did you say? Assuming all of the things...
Assuming the density of all the potatoes is equal, and that all the peels are equal and that the piles are stacked the same way, it would be the smaller ones because they have more surface area.
The smaller ones would have more surface area?
Yeah, because since you're basically grabbing the whole weight, if the density is the same, there's the same weight per area, and so it's kind of like the little model you showed us. Instead of having the big potato,
Why don't you make that
divide
little
it
model?
in
Why don't you make that little model?
Okay. So
This would be, what lab did we do this in?
this was the concentration. No, so that was
Rates of reaction?
Yeah, rates of reaction. Okay,
Make
so
one 4x4.
4x4.
No, I'm sorry, 2x2.
Oh, 2x2.
2x2x2.
Alright, so
Okay, now let's pull that aside.
alright, so if I have these, my total surface area is 4 times 6, because you have 4 here, times 6, and that gives you 24. So that's your total surface area. But if instead you have the smaller
Yeah,
potatoes...
there's 8 separate ones you can use.
Okay, so... Oh, right, sorry. So you have this, then you have another.
So what's the surface area? Oh, no, break that, keep that broken.
Oh, keep that
So
broken.
what is all the surface area of that
So
together?
this is 1, 2, 3, 4, 5, 6, 7, 8 different squares, and that's the volume. But you multiply the ones on each side by 6, so that's 6 times 1, that's 6, times 8 squares, so 6 times 8, 48.
Right. So this one has a surface area of 48?
Yeah, and this has
one
24,
has...
so it's twice as much.
So this one would have, in this particular example,
Yeah.
how much more skin?
Twice as much.
Because there's more
Yeah.
surface.
So
All right. There's one thing I want to help you with. Give me 1 second, and I'll get right back to you. Yes. Take and do that same problem with your calculator. Take 168 divided by 56.
168 divided by 56 equals 3. Alright. That was probably my math.
So I'm wondering.
Yeah, all right, so let me
So we can say that
again.
this one is 3 times taller,
Yes,
so therefore how much more paint would it use?
3 times.
Now,
No,
you also wanted to talk
Plus
about,
width, so, let's see. This is 6 millimeters, we already have 18 millimeters. But the width, I still have no idea how to factor that in.
how, if you're squaring the dimensions,
So if I square them,
huh? If you
So
square the
say I'm-
dimensions
yeah.
bigger, right?
so I'm squaring that, so that would be 18 times 18. 324 milliliters.
Okay.